Okay, so I'm going to be going over this new Python version of ProcessNet and kind of starting from scratch. So if you don't know programming or don't know Python, I'm going to kind of start from the very foundation. Quick summary, this will be a pretty quick presentation, but these are the points I want to hit. So covering at a very base level what Python is, how the Python ProcessNet compares to the Visual C# or Visual Basic versions of ProcessNet. And then going over what ProcessNet can do in general. I'll do a live demo showing an example that I think was suggested by a customer, and then I'll point you towards how to get started, where the relevant documentation is, and things like that. Okay, so from the very beginning, Python is a general purpose scripting language. So it's used really commonly in like data analysis, data processing. It's an interpreted language, which means there's no compiler. You basically have a text file and you use Python to run it, and it handles all of like the nitty-gritty stuff behind the scenes for you. So it can be a really easy language to get started in, and it can be an easy language to like prototype code in. So you might have a long-term goal of writing a C# ProcessNet application, but you can sort of prototype minor functions or components of it using the Python area. The syntax is pretty straightforward. There's obviously going to be some quirks like any language, but it's a quite readable language, and I think it's really easy to get started with if you have never used programming or never used Python before. This might be my favorite part of the language. I'm a huge Python fan, and it's a super widely used language, so it's very Googleable, for lack of a better word. And that means if you don't know how to do something, usually somebody on Stack Overflow has already figured it out, and you can sort of modify that code instead of having to start from scratch. And there's a lot of libraries available to do the types of things that you might want, and kind of do that in a few lines of code rather than having to write something from scratch. So you can do networking things, you can manage files, and we'll see a little bit of that. You can do a lot of data processing. There's a library called Pandas, because the open source community can't name anything. But it's a really nice environment for doing a lot of data processing. You can build GUIs, though if you want to do a lot of GUI work, I'll mention this later, it's probably better to do in C#. And you can do plotting, and part of that is sort of included with Pandas for the data processing. Now, how does it compare to C# or Visual Basic? So to begin with, when you're running C# or Visual Basic ProcessNet code, that's really launched from within RecurDyn. So you'll have RecurDyn open, and then you'll click a button there, or you'll use the run area to run an application or run a function. With Python, you can do it external from RecurDyn, and we'll see that as I'm using an IDE to run my code. Now, one sort of downside is that you don't have access to Windows Forms. That's something that's built into Visual Studio, and it's a very approachable way to make simple GUIs or even complex GUIs. Python does have tkinter. That's like the standard library GUI builder, but it's definitely less user-friendly than like the form builder in Visual Studio. So with Python, you get all of the Python data processing libraries. Those might be a little bit harder to find or a little harder to use in something like C# or Visual Basic. And anytime you change something in C# or Visual Basic, you have to recompile it. And if it's a registered DLL at that point, you have to close RecurDyn and reload RecurDyn so it reloads that DLL. With Python, it's really easy to just have a script, make some changes, and then rerun it without registering that application. So it can be, especially for prototyping code, a much easier workflow. And I think in general, if you are not an expert in C# or Visual Basic or programming in general, it's a lot easier to kind of get started. And if you have maybe the person on your team that is a programmer, they can write, a foundational script, and then non-programmers, so to speak, can make small changes to that code very easily because it's a very readable language. So some things that ProcessNet can do, the way I like to think about it is that the ProcessNet APIs or functions essentially allow you to click RecurDyn buttons programmatically. So if there's a process that requires 10 buttons to click in succession, you can just write code to do that for you, and not have to worry about each individual click. And that makes a huge difference when you have to do something a bunch of times. So there's a really good example in the tutorials for ProcessNet where they end up needing to make dozens of contacts, and that's a really tedious process. But with ProcessNet, you can just make a loop and in 10 lines of code create all of those dozens or hundreds of contacts or joints or whatever the case is. So if you have something that's highly repetitive and can be described pretty simply, it's a lot easier to do that in code. Another thing, and there's like templates are available for the plotting environment. So you can do some automation for plotting, but if you want to do something more custom or you want to change it more frequently, you can use ProcessNet to pull data from the plots, from the result data, and then create your own plots that only have the details you care about. So some of it kind of depends on what your exact needs are and whether using a code approach or using kind of the built-in automation and customization tools is going to work better. You can also add commands to the ribbon, so this does apply for both Python and the C# Visual Basic. When you're using Visual Studio, it's going to be easier to use the form builders in Visual Studio than to use like tkenter or PyQt is another GUI builder. But if your organization has some kind of highly customized workflows that need to be done frequently, but there's decisions along the way, you can build custom GUIs that allow you to sort of guide your users along the model creation path or model update path. So there's less effort required to make complicated changes. And kind of going along with that is enforcing best practices. So there's having a Word document with here's the instructions for accomplishing this task. That can be kind of tedious to go through. Whereas if you have a guided process using dedicated GUIs, then it's harder to click the wrong button or make a mistake if you're doing that. And another thing that you could do is if you want to validate a model, you can use code to loop through an entire model and make sure everything is set properly, or you haven't forgotten something, and just sort of avoid a complicated debugging process. And with that, I'm going to jump over to Visual Studio, or sorry, VS Code and RecurDyn, and we will sort of see this in action. So the goal for this example is something that you can't really do cleanly using any of the other automation tools. I think you could do it with eTemplate, but it would be a little bit tedious. If you wanted to run the same model across a bunch of different grounds, right? So this ground is defined with an outline, and then the ground is made with an outline here and over here. And if you wanted to run like 20 or 30 different ground track examples, it'd be annoying to do that manually. So the goal for the code is to automatically go through these outlines, make all those updates, run all of the models, and then ideally you come back 5 or 10 minutes later and everything's done. So I ran the full model before this. So I'm going to drop this down just so we can sort of see things happening a little bit quicker. Did not want to simulate it here. So this is VS Code. There's, in the documentation, which I'll talk about more towards the end, there's the instructions for how to set all of this up. Once you have it set up, it's pretty straightforward, and it's not difficult to set up initially. So I'll go through this code in more detail afterwards. But first, I want to run this so we can see kind of what's happening interactively in RecurDyn. This, we'll see if it starts. So we can see, yep, now it's going through and it's going to update those outlines, recreate the ground, and then run the simulation. And while this is running through, I'll kind of talk about the other things the application is doing. So it's getting all of the ground data from an Excel workbook. There's a sheet corresponding to each path that the ground has to take. And then it's applying that data to the RecurDyn model, running the simulation, which is what we're seeing right now. Then it goes through, pulls out some sample data. So we'll see that in a second. You could pull out whatever data is actually relevant that you want kind of summarized. And then it saves out an Excel file that only has the results that are of interest. We'll see it go through. We'll watch it do one more, and then I'll go into the code in more detail. You can see it made another change to the ground. So while that's running in the background, let me go through this, what it's actually doing. So it's reading through this book 1 XLS, which I have here. So this is Pandas code. Like I said, the open source community can't name anything. But it reads this Excel file, parses it out into each sheet, and then runs this run function. So if I scroll up to this run function, it sets some model simulation parameters that we're going to set here so that everything gets put into a single folder, and then I'm going to reset that at the end. It creates a dictionary to store all of my results, and then it goes through each sheet in the Excel workbook, and then it passes it to this make road from DF. That's a data frame. That's what Pandas calls their data objects. So it provides the sheet that I need, and then the ground object. So that's what this dummy body is. Every subsystem in RecurDyn has a dummy body, and that is shown as ground in the GUI. Then it's going to redraw the 3D window so we can see that. That's really more for demo purposes than anything. And it sets the output file name. So if I go into the example folder where all of my results are being saved, each one is named correctly. So this is another thing that if you're doing everything programmatically, you can enforce naming conventions a lot easier than accidentally having typos or something like that. So we see this nominal, and then sample 1, sample 2 goes through all of those. And it runs the actual simulation. There's a couple of different analysis modes. So those correspond to the different simulation modes in RecurDyn. Then it goes through it creates a plot document. So if we look over here, it's creating all of those plots just so it can pull in the data. Because I know what the name is, I set it programmatically, I can grab the rplot file of interest. So as an example, if I just wanted to do post-processing, if I knew what all of my rplot file names were, I wouldn't have to run the simulations with code. I could just be doing post-processing with code if I wanted to. Then it's going to pull out two things from the plot data, the time and one of the reaction forces. This really could have been anything. I just needed something to throw into a results folder. And then this is a Pandas thing again, where I'm just summarizing all the data, what's called a frame, and then adding that frame into a dictionary. So this is going to be used later to write out a summary Excel file with all of the data that I want. Now, if we go up to the make road from DF, at this point I can mention the initialize and dispose functions. These are part of the template that function bay provides, and this is, like it says, initialization code and what I'm going to call teardown code. So it just kind of cleanly opens and closes ProcessNet. This you can sort of just leave in there unless you have a reason to change it. But this make road from DF, what it's doing is finding all of the outlines that are in the ground object, and then it's going to update them to contain the new data corresponding to what I gave it in the Excel sheet, right? So this first section of code really just makes sure that it has enough points to fit all of the data that I'm providing it, and then it's going to go through each point in the outline and set the point values based on what I've provided. Then I have to switch. This is a ProcessNet thing that you'll encounter. You have to change the context that you're operating in. I won't go into detail, but I just have to switch to the ground. This is really changing to body edit mode, basically. And then I'm going to remove the existing road data and create a new one. And then I'm going to switch back up to the main model. And I end up just looping through that every time that I need to make a change to the geometry and then run the simulation. Then we can scroll all the way back down to the bottom. This is the last thing it does, is it saves out a results file. Oh, I was supposed to change the name of that. We can still look at the data. So it saves out an Excel sheet or an Excel workbook with one sheet for every simulation that I ran. So in this example, we only have two things that are showing up there, but you can imagine a scenario where you have 25 things that you want from every simulation in a run, and that's kind of tedious to go through and grab from the plotting environment. So if I can just summarize that all into Excel, a lot of times you're going into Excel anyway to do post-processing, and then to copy into PowerPoints to show to people. With that, I will actually open up that Excel file. Everything opens on the other window. So we can see that I have the time series and the actual data. So this is the reaction force on one of the track links. Now I could go in and this one's not very interesting. This is only 1 second. So I don't think that track link actually makes contact with the ground. We have the exact same thing for all of these sampling points. And you can imagine that if you had a large series of simulations to run, this definitely makes your life a lot easier. And like I had mentioned, without having to close RecurDyn or anything, I can make changes to this script. Like let's say I wanted to change the actual file that's being written. I can do that and save the file and then go ahead and run it. And it'll do everything all over again. This code assumes that I'm starting with this open. Yeah, so I think that really sums up everything I wanted to show. There's obviously a lot of different ways you can automate things within RecurDyn. You can use parametric values, parametric points, eTemplate, the DOE functionality that Nelson's going to be talking about. And I think knowing what all the tools are really allow you to choose the best one for the job and then, simplify your modeling life. So with that, I will switch over to how to get started. So there's a template, and that's actually what I used to grab that initialize and dispose code. So that's a really good place to start. And then you can modify the example from there. It's going to be in the RecurDyn install folder. There's a bin folder, and then you'll see Python. And then there's this Python, this ProcessNet template.py file. You can open that into VS Code or any editor that you like, and then run it from there and start tinkering around. Really easy to see immediate feedback for what you're doing because you can just run it and see what happens. So I've mentioned VS Code, and if you go into the ProcessNet help, there's a guide for installing VS Code and installing Python. It's really just running the installers for those codes. It'll probably take longer to get the IT departments to allow you to install them than to actually get it up and running. Then there's ProcessNet help. So the RecurDyn help has the instructions for installing Python and VS Code, and then the ProcessNet help has specific documentation for all the functions that are available, what kind of parameters they take in, and there's a lot of reference code as well. So you'll see at the top, and I'll open this in a second. So there's examples for all of the toolkits, and then there's core examples that has everything from the professional area. So these are going to always be available. And there's example code for setting up buttons in the UI, using road data, all of that sort of thing. So that quickly, and then we will stop the script. So this is the ProcessNet documentation, and you'll see the C# and Visual Basic, and then Python directly below it. So these really have the same content. It's just the names of things are a little bit different, or the syntax is a little bit different. So if we go into Python here, you see the examples. So auto design has its own examples. Chain, all of these things have their own examples. And then core example is especially where you'll get started. And there's examples for all of these different functions that you would want to use. You keep scrolling, the actual documentation for what each function takes. Like if I wanted to know what methods are available for body objects, I would go here, and I can see, I can change the density. I can see which sheets are in that body, which solids are in the body, all that sort of thing.